So my name is Victor, and today we will talk about Annex, and we'll talk about two different styles of monorepos and why Annex is cool in that it can do both really well. So what is Annex? Annex is a smart, fast, and extensible build system. So title basically, right? Built for monorepos, that has first-class support for monorepos. And the word monorepo here is important, right? It's important for two reasons. First, a lot of folks who use Annex for the monorepo use case, whatever they think monorepo is, right? And the second reason why it's important because it's poorly defined, it's ill-defined, right? So there are many ways to do monorepos. They have nothing to do with each other. They're different styles, right? So in this talk, I will explain the two main styles, the way we see them, right? How Annex can do both, and that's why I think we see the growth that we see. That this year is an amazing year, to a large degree because we can do the two styles really well now. Okay. So Jeff did a keynote right now, or was the pre-keynote somehow, right? So he kind of showed the numbers. So you see the exactly same numbers, but in my when I talk about the numbers, it makes more sense because they're in the context of a larger theme, right? They're not just by themselves. So it's a keynote, so some numbers, so it's less dry, right? So that's our growth for the last 2 years, NPM stats. Here we can see a lot of popular monorepo tools in the JS space. I would say most popular monorepo tools in JS space. So 2 years ago, you can see that Lerna was basically the only really big player. Right? Lerna is red on this graph. You can see it on the left, right? Annex was number 2. Was about 20% of Lerna at that point. So they're still big, still widely used, right? A lot of companies use Annex to build amazing things, right? 2 years ago, and everything else was much smaller, right? So in the last 2 years, Annex went up. I don't know, something like 15x, went up quite a bit, right? We also took stewardship of Lerna, as Jeff mentioned, this year. So now when Lerna runs tasks, it basically uses the same machinery that Annex uses, right, to run tasks. So what you see on the right-hand side right now, which is Annex and Lerna, they basically run tasks in the same way. Right? Two different tools from the point of view of the user, but actually do the same thing when it comes to running tasks. Right? They're very similar. The exact same information about the state of today, right? But in a pie chart form because it looks more impressive, right? Essentially, Annex and Lerna in total, right, account for most monorepo usage in the JS community. NPM stats is not a very good way to measure adoption. I don't think there is a good way at all. There are just many different numbers we can look at. So it's very hard to know what exactly, the piece of the pie that Annex and Lerna account for. Right? Is it 2/3, 75%? We don't really know, but we know it's a big part of the pie, right? The majority of it. And if we look at other numbers, we sort of see similar exponential growth, right? A number of Annex Cloud users goes up, Annex Dev traffic goes up. We can see that everything is growing, right, reasonably well. We don't know exactly how much the community is growing, but we can probably conservatively say about 3.5 times per year or something like that. Right? So it's cool. So it's a good result and hasn't slowed yet, which is, again, I think it's very nice. So I want to tell you how we got here, right, and how Annex evolved over the years and why we see the numbers we see right now. Right? To do that, we need to travel back in time to 2017. Right? If you don't remember what it was something like this. Okay, that was the only piece of humor. There'll be no more humor in the presentation. That is like a mandatory injection of humor, so it's less dry. From this point on, it's only serious stuff, right? Because it's not the monorepos is not a joking matter. Okay, so in 2017, we decided to tackle the following problem. All right, and the problem was that if you are trying to build a massive system or set of systems, right? Like a big application or many applications, and you want to share code between them, you want to partition them well, you want to make sure they're maintainable, you want to make sure that hundreds or thousands of engineers can contribute to that system effectively, right? That's basically what was a use case, right? So it's a different use case from what Lerna, for example, was built for, right? So we had that use case in mind, and we thought about it super hard, right? And being like ex-Googlers, who basically sort of got inspired by what Google does, and we did the same thing. We built a monorepo tool. Right? Google solves this problem using the monorepo approach. Right? And the focus, again, was not to don't worry about reading individual items, right, in here. It doesn't really matter, right? Wasn't not putting 10 things side by side, right, in a repo and running CI reasonably fast. It wasn't splitting like a large graph, right, or a large system into a large graph of hundreds of thousands of modules and being able to interact with those ergonomically. Right? So you can see what's affected, but what changed. You're able to make changes to that giant system in a reasonably good way, right? So you sort of gain a lot. Your gains are high, and your costs are low or manageable, right? That was the goal. It was very different from the other thing I will talk about in a bit. So I call this style of monorepo. We have this large interconnected graph of nodes you can compose into apps. Google style monorepo, because that's roughly what Google does, and Meta and Uber and others, right? Other folks on the team didn't like it because that's not descriptive for those who don't know what Google does, right? They're like, well, I mean, if I don't know, it doesn't tell me anything, right? So we renamed it, and now we call it the integrate style or the integrate monorepo, because the whole dev workflow in this case, right, is built around the idea of a monorepo. So there is a lot more integration of different parts that has to happen to make the experience good, right? And there are a few sort of key points that this style we think is good for, or like it has, right? The first one is there is an emphasis on applications. So it's not just on building packages. You're actually building things that run on a server or in a browser, right? Some percentage of packages can be published to, say, Nexus or NPM registry, but it's not a large percentage. So most packages in this style of monorepo are consumed from within the monorepo, right? They're there not to be published, but for the purpose of like code reuse, performance, just structuring code, factoring code in the better units, etc. Right? There is single version policy, which means that if you have two applications in this repo, depending on, say, one version of React or Angular, right, or depending on React or Angular, they're going to use the same version, right? There is a strong emphasis on ergonomics, not just speed. It has to be fast, and I'll talk about how we do it, right? But the ergonomics is kind of more important, right? Because that's the first problem you encounter, is that things are just hard to do in a monorepo unless you pay attention to it, right? And finally, it does automatic migrations, where you can move from one version of NX or React or Angular or whatever to another one in a mostly automatic fashion, right? It does like 90% of the work for you, right? So that's what we did, right? We focused on that problem, which was important, especially for like large companies, enterprise, and stuff like that, right? Meanwhile, the JavaScript community did something else, right? And something entirely different, right? They have a very different take on monorepos, and we call those package-based monorepos, right? If you look at, for example, the 3 big UI frameworks, they all use package-based monorepos using different technologies, right? But fundamentally, it's the same style, right? A lot of open source projects use this style. A lot of closed source projects use this style. So it's actually very popular, right? And Lerna was basically the only widely used tool for many years for this style of monorepo. It was huge, right? And it's still the biggest player to this day. So in this style, in the package-based monorepo, right, what you have is multiple NPM packages side by side, right? They depend on each other via package.json, right? And then the package manager, like npm yarn or npm, would link them such that if you use package A and package B, and say package B depends on package A, right? Package manager would put the package A in the node modules of package B such that when you import package A, it's visible as if it was installed from npm, right? All your actions in this case are expressed in npm scripts, right? So it's basically all about npm packages working together in one place. That's basically the whole style, right? There is a very strong emphasis here on publishing, right? Every package has package.json, has node modules, right? And many of them are published, not a small percentage. So no wonder that the leading tool in this, for this particular style, Lerna, right, is a publishing tool. Right? It's not an accident, because publishing actually is very important, right? There is no single version policy. You have multiple node modules. You can easily have multiple versions of React or Angular, right? And the focus is less on ergonomics and more on just, let's make it reasonably fast kind of stuff, right? So that's what the tools that implemented are built for this style are trying to do, okay? So the first 3 years, we didn't care about this style. We only looked at the integrate style, right? We tried to polish the dev experience, make sure the experience is good. You can actually have, hundreds of developers or 1,000 developers contributing to the same system. They can establish constraints, make things consistent, etc. Right? And we also put a lot of effort in making it fast. Because integrated repos tend to be much bigger than package-based repos, so being fast actually matters more, right? Let me show you a few examples, a few small examples of what I mean by we polish the developer experience, right? Because the DX part, it can be vague. I mean here a very particular thing, okay? So here we have a repo with 2 packages. There is an application, and there is a library of UI components, right? So if I go right now, the application is served, as you can see, right? If I open the component, right, the header component from the UI library, and I make a change to it, what is going to happen is that you will see the change reflected in the app, okay? So that's, it's not very impressive, right? If you look at it like, oh yeah, like, okay, good to know, right? But it matters, and it matters for the following reason, is that it's easy to make this experience of I make a change to a piece of code and I see it right away reflected in the browser, right? Work for a small single node repo, right? You have a single node repo, everything is loaded into memory, just one thing, right? Making this experience work for that use case is actually not hard, right? Or rather, like all the tools we use implement this, right? Where it gets problematic when you are embracing a monorepo. You're saying, okay, I don't have a single node small repo, I have a massive repo composed of 1,000 of nodes. So which brings me a lot of benefits, right? I have like incremental builds, blah, 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 coaching, and lots of nice things, but there is a cost, right? And here there is no cost, right? So the developer experience kind of matches the experience you get in a naive small case, all right? So you get the benefits, things are faster, code sharing, and you don't pay the cost. You maximize the gains and you minimize the cost, right? Another example, the same stuff that is kind of obvious when you don't use a monorepo, but actually doesn't work in package-based monorepos at all, right? So what happens here is that same application, there is an app, there is a library of UI components, right? If I try to navigate towards the component, it will go to the source where the component is defined. All right? Not to some dist folder or not modules, it goes to the source, find usages works, refactoring works. All right? So all the things you would expect work normally. I can do all the things I want to do with VS Code, right? Now, if you build this app, right, what's going to happen is that it's going to build the library of components first, and it's then going to build the app, consuming the library of components from this. As you can see, there are two things that build here, the UI library and the shop app, right? So if I build it again, like if I make a change to the app and I build it again, you will see that the app is going to be rebuilt, but the UI library is not going to be recompiled because it hasn't changed, right? It was retrieved from cache, basically, right? So again, so you kind of get two things that are hard to reconcile. Individually, the two things are not that hard, right? On one side, you want to have a developer experience where I can just go and use VS Code or IntelliJ the way I would use without a monorepo. I can just jump around, between classes, rename them, do things, and it should just all work fine, right? That's one use case, the editor experience. On the other side, you have the build setup stuff, right? Where the build doesn't want to go against source. But if I compile UI to a dist folder, right, the UI library to the dist folder, the build process for the app should consume it from the dist folder, right? That allows incrementality, right? I can get all the compiled artifacts from cache, for example, right? So if you want to get both, that's where it's hard. So NX, in this case, the integrated style that NX provides gives you both, right? You get the performance gains, your builds are fast and incremental, right? And you minimize the cost. Your editor experience actually as is, right? Doing this in a package-based style monorepo is very hard, and most of them don't do it well, right? You basically often have either slow builds or broken editor experience, right? So that's sort of the developer experience umbrella, right? You preserve the DX of a simple repo, right, of like a naive setup, right, while getting the benefits of a monorepo. Okay? The second part is we were working hard on making NX super fast, right? And there are three parts to making NX fast. One is task scheduling, being able to run tasks effectively, being able to run only what's affected by your PR, right? And finally, it is caching. Okay, so let's talk about caching first, okay? The way caching works in NX is that anytime you run any command, let's say you're running an X-affected build, and it looks at your repo, at your PR, and figures out that 20 things have to be rebuilt for this PR to be validated and stuff, right? So what NX is going to do is going to, for each of those 20 things, compute a value based on the hash inputs, right? Which it takes source code, runtime values, that compute this value that basically describes the computation. It then looks at your local cache, which by default is stored in node modules, to see if this exact computation has happened before. If it happened before, it's going to replay it. It's going to print the terminal output as if it's running right now. It's going to put the right files in the right places, right? If the computation hasn't happened, it's going to basically run it, right, and then put it inside the cache, right? So conceptually, it's actually very simple. It's basically like find and create, right? You either have it, in this case, you just use it, or you create it, and then for later use, you can reuse it in the future, right? Conceptually, it's very simple. What is interesting here is not the conceptual part, because every tool right now does something like this, right? It's the implementation details, right? So the devil is in the details here, right? For example, the output capture that NX does, right? When it figures out what your output is for later use, right? It does it better than other tools because we like patch, not the JS context, right? To get the output as is, so it's not like changed by the fact that caching works, right? An X daemon, the process that runs in your repo, would watch all the output folders you have, such that when you try to restore things from cache, it will check if the folder you're restoring into already has the version that you're trying to restore. In this case, we'll skip it. If you change something in that folder by hand, it would know and it would restore it, right? Things like that. There are a lot of things like that that make this feature very hard to build or to build right. But conceptually, it's very simple, okay? And of course, because Jeff already mentioned xCloud, the cool part here is not that cache works locally for you, which is good. I think what is cooler that you can share it with your teammates, right, and with your CI. And especially the sharing with CI, what gives you a lot of benefits, because the CI in this case would run compute, right, would populate the cache, and then when you, pull changes in the morning and you run some command, everything will be retrieved from cache because the CI has just done it, right? So everyone in the JS space, in the Monorepo space right now, right, in the JavaScript community, is excited about caching. Right? Caching is easier to get right, conceptually at least, right? So people know about it, they love it, right? The second part that's actually cooler than caching, it just takes a bit harder for, it takes longer for us to convince people why this is what they want to use, right? Even though I think in the long run, this is the bad thing that can happen to your repo, right? This is very good. So distributed task execution works as follows, right? So if you don't know, if you imagine like a simple CI process with a single agent, right? What that agent is going to do is going to test and lint and build things in order, like one project at a time, create an artifact. That of course doesn't scale very well. Nothing runs in parallel. It's not great, right? So the first thing everyone does is they move to the model that looks like this, where essentially they run things in parallel, right? And they only run what is affected, right? Meaning that if your PR couldn't affect a particular application, it's not going to rebuild, retest, or relint it, right? You have this. This is better. Right? You can go a bit further this way. Some things can run parallel. It's not bad. But of course, it's also constrained. It's a single agent, so it only works for relatively small repos, right? Anything that's bigger than like a medium-sized repo, this can get slow, right? So then what people do, right? They start sharding tasks across agents, right? They take, say, all the builds, run on one machine, take all the tests, run on another machine, take all the lints, run on the third machine, or something like that, right? And they can do some sophisticated things and say, well, we have a lot of longer builds. Let's split builds into two machines and figure out a way to partition basically builds, something like that, right? You could do that. Fundamentally, though, we can talk about it at length. I don't have time right now. But you kind of hit a few walls, and it's very hard to make the utilization across agents even, right? So no matter how smart you are and how much you optimize, you'll end up with something like this, where for some PRs, one agent is going to take a lot of time, and other agents will be done. And it doesn't really matter that agent 2 and 3 are done, because you still have to wait for agent 1 to complete. All right? So that unevenness of utilization constrains how fast the CI can get, right? And that's a big problem, right? So what distributed task execution does is says, instead of sharding by target or something like that, right? How about we basically run the commands in a naive way, as if it just runs on one machine, right? But instead of running on that machine, we're going to tell xCloud, the coordinator, that I would like to run all the builds and tests and lints. And then xCloud can delegate those tasks to each agent. So in this case, a particular agent is not responsible for all the builds or subset of builds. It can run anything, whatever it was told to run by the coordinator, right? That allows it to achieve a much more even utilization and actually drastically reduce the CI time, right? The cool part here is also as your repo grows, when you have more and more things in your repo, more things to build, to test, right? You can simply allocate more agents. So you can vary the number of agents declaratively and keep your CI time reasonably fast, right? No matter how big your repo is, right? Finally, and that's, I think, perhaps one of the cooler parts, is that if you add dependencies across tasks, for example, here, imagine end-to-end tasks depend on builds. Like you just have to have build artifacts to run end-to-end tests because you're going to serve the build app, right? The distribution that xCloud provides would fetch the right files from the right agent, right? And would send them to the agent that needs them. So in this case, the agent 2 would get the files from agent 1, agent 3 would get the files from agent 4 without you having to do anything, right? So that's the idea. So basically, the mental model with distribution is that you get the ergonomics of running things on one machine. It feels like you run on one machine, etc. But it's fast, right? It scales a lot better, right? So you maximize the gains, like the scaling is very good, right? And you minimize the cost. There is some complexity associated with it, of course, right? But it's fairly small compared to, say, sharding, right? Anywho, so that's what we had. We had it, and at that point, we realized, so we have this, like a cool piece of technology. We're super fast, right? Our caching stuff is much faster than anything else, right? We have the distribution thing that really no one in the JavaScript community does, right? How about we apply it to the other style of the monorepo, to the package-based style, right? Until some point, we only focused on the integrated style because we really think for a lot of applications it's much better, right? So we started applying to the other thing, right? So about a year and a half ago, it became a priority for us, right? So first, we built a preset that allows you to create an NX workspace with a package-based monorepo style, right? We added a command you can run, right? And it would take your package-based monorepo and annexify it within like a minute. We'll ask you a few questions, right? And by the end of it, you have it, right? You can push it. You can merge into main within like an hour, right? And get huge performance benefits, right? We cleaned up our config. This is an example of a small config. Actually, you don't have to have any config right now to use NX in your monorepo, right? Most of them you have some, but it's like a one file with 20 lines, something like that, right? So we cleaned up config. We reworked our docs to emphasize the package-based style. Right now, if you go through, this is actually not the latest version of the docs. It's better now. Where if you go to the docs and you just want to do the package-based style because that's what you like or that's what you have, there is a clear path on how to do it. All right. That's a lesson for me, Victor. That's a picture of me, blue hair, handsome, right? So that's yeah, that's a good picture. And there is actually, I'm actually rolling a child in a stroller. The child is cut out. so anyway, and the lesson for me is like even if you get the fundamentals right, and I think we got the fundamentals right at that point. We're faster than anything else. We had distribution, like we rocked, right? If you don't have good docs and good onboarding experience, it just doesn't matter. Right? You could say, well, it's only an hour of work if you know what to do. It simply doesn't matter. Right? You need to have a good onboarding experience, a good packaging for your fundamentals. Right? And unfortunately, for the package-based style, for the first couple of years, we just didn't have it. Right? It changed in the last year. Also in 2022, took stewardship of Lerna. Really like Lerna, amazing. Great respect for this project and the maintainers. So we updated the docs website. Started triaging issues, fixing bugs. It's in a much better shape right now. Right? And one of the things we've added to Lerna is we integrate with NX. So if you want to actually just run your task very fast, NX is very good at it, right? So we integrate with Lerna. And now if you have a Lerna 6 repo, what you can do, you can run Lerna add caching command, right? It's going to ask you a few questions, right? What things need to run in order, what is cacheable, where files are created, basically. And by the end of it, right, this is a very simple repo. You're going to get an NX.json file that is crafted for, crafted is a very strong word, it's created for your repo, matches your repo, right? Usually for real repo, it's going to be a bit bigger than this, right? But it's still a fairly straightforward process. Like going from Lerna without cache and distribution to a Lerna repo with cache and distribution can be a matter of 20 minutes, something like that, right? So more numbers, because keynotes, and keynotes like numbers, right? Okay, so at the beginning of 2022, that was our usage looked like. The majority of our usage was integrated. Package-based was there, but wasn't like the biggest deal for us, right? So now it's different. You see the package-based share is growing. And it's growing, even though the integrated share is growing as well, or the integrated section is growing as well. Right? There are more and more users using NX, and the percentage of those who like the package-based style, right, is increasing, right? And by the end of this year, it's going to be probably 50-50, right? So it's a big deal. So when we look at this crazy growth, a lot of this, like a bigger spike, right, is due to us actually supporting the package-based style well, right? Something that we didn't do before, and now we do much better. I'm actually out of time, but it doesn't matter. Let's keep going, right? So NX is unique, right? And I think that's a killer feature of NX, that it can do both well, right? the two styles seem like they're opposite of each other, and they are in so many ways. They're very different, right? But it doesn't mean you cannot combine them at all, right? So if you look at tools right now on the JavaScript tools for monorepos, you'll see that there aren't that many integrated style monorepo tools in there. So why is that? Very few contenders, right? Because it's hard to get it right. It's just harder to get that style right. It has a huge potential. If you get it right and you actually embrace it, you can scale things better. It's very good for you, right? As for example, Google shown, where like it's a supermassive mega repo, right? And they could do it, right? This style is really good, but it's hard. Package-based monorepos are much easier to move to. It's much easier to build tools for and move to as a project, right? Huge advantage, right? So what you can do though, you can start with a package-based style, right? If you have an existing monorepo, annexify it, using the package-based style. The first day you did it, you merge into main, you get performance benefits. Your CI is 3 times faster, something like that. Okay, it's great, right? And then add a little bit of Annex plugins on the side where you feel they provide the most value. For example, if you have the 50 libraries built with, say, Lerna right now, or with something like that, right? And you have them, they're cross-stitched by PNPM or Yarn or something like that, right? You could add an Annex plugin for Webpack or React, right? Add the React app and have the dev experience I showed you, where everything updates, it's smooth, it's cool, right? So you can actually get it, right? You could get a lot of it almost kind of for free, right? Where you can sprinkle some integrated style on the sides and get a lot of DX, right? With relatively minimum effort. So you don't have these two extremes where you either have to invest years into Bazel till you see huge progress, right? And Bazel is cool, but it's a lot of upfront work, right? Or you're not in a place where you move to the package-based monorepo. It is cool, but then like 2 years in, kind of doesn't scale. Right? You have too many packages, it's too clunky. You can actually move to the package-based repo and then slowly move to more like a mix of the two, right? What's better is that Annex, of course, can do both. So that's why it's like gradient color. Gradients are cool. You can see Lerna is gradient colors there as well. That's not an accident. Boom, animates away. Right? So, because Lerna can do the same. Right? If you have a Lerna 6 repo, you can add cache into it, get all the performance benefits I mentioned. Cache and distribution all works, right? Like same day. You can merge it same day. Things are fast. You're happy, right? And then, at some point, you can sprinkle some Annex plugins on the side, and it will work fantastically well, right? You have this beautiful sort of hybrid style, right? Of mostly package-based with some integrated style for, say, building apps or running end-to-end tests, something like that, right? That's about it. Thank you so much. Follow us, and talk to me, right? Thank you.